Hello everyone. So today's class is just started. So before I start, I have a very good news for all of you. So yes, just let me check whether I am audible and visible so that I can show that message to you. Just give me a second. Yeah, so so basically there is a good news for all of you. So you are saying that who is going to teach chemistry. So we have our chemistry teacher, so she will introduce herself. So just a small
hello everyone, I am Swati Hegde, your chemist.
Just a second.
Hello everyone, I am Swati Hegde, your chemistry teacher. I have completed my MSc B.Ed. With 6 years of teaching experience, I have learned that chemistry is not just about formulas and reaction. It's about understanding the science behind everything around us. My goal is to make chemistry simple, interesting and fun for all of you. Together, we are going to explore, experiment and discover the magic of chemistry. Looking forward to an amazing learning journey with you all. See you soon.
So Swati ma'am will start taking chemistry classes from tomorrow onwards. So those who are wondering that who will going to teach chemistry, so Swati ma'am, very experienced well enough, she will start taking the classes from tomorrow onwards. Okay, so today our chapter electric charges and field theory portion is over. So it's time for us to discuss the PYQs. So we are going to discuss 25 very important PYQs, including 2026 PYQs. Okay, so it is not only the 2025, 24, 2022, not like that. We will start with 2026 PYQs as well. So let's start with the first question from 2026. An electron falls through a distance of 1.5 centimeter in a uniform electric field of magnitude 2 into 10 to the power of 4 Newton per Coulomb from rest. The time taken for to cover this distance in second is electron charge of an electron is given, mass of electron given, and they are basically asking you the time taken. Very interesting question, but if you follow basic principles, it is not a difficult question. So what is the basic principle? When you keep a charged particle inside an electric field, what happens to the charged particle? It experiences a force. What is that force? The force experienced by the charged particle is given by Q into E. Right, so this is the force experienced by the charged particle, and our great grandfather of physics, Newton, told us that father is equals to ma. Okay, Newton was Indian, just joking. So father equals to ma, and from there we can say that acceleration of the charged particle can be calculated as A is equal to Q into E divided by M. So acceleration is known. Okay, now we have to distance given here is 1.5 centimeters. So that is the distance traveled by the electron. So distance is also given. So what else is left? We just need to use the basic formula of motion, that is S equals to ut plus half at square. Now here obviously the electron starts from the rest, so u is 0, so you have just one thing left, that is half at square. So S equals to half at square, right? So S equals to half at square, A is known, we have to find the time t. So time t, t square equals to 2s divided by A. Right, so if you put the value of A in this equation, you will get 2s into M divided by Q into E. Obviously A was in division, that's why this inverted. Right, so now we have to take the square root of this entire thing to calculate the time. Now we will come to that in a while, but let us put the values here itself and try to simplify it. So what is the S value given here? S value given here is 1.5 centimeter. So be very, very careful. As soon as you see a value, do not put the value. You have to convert it into SI units. So for example, here 1.5 centimeter is given. So you have to convert it into 10 to, meters by multiplying 10 to the power of Shiv Charan is already answering option A. Okay, maybe he already has solved it or know the answer. Let's see. So 2 into 1.5 into 10 to the power of minus 2. You have to convert it into thus SI unit. Mass of the electron is given 9.11 into 10 to the power of minus 31. Okay, divided by Q into E. So what is Q? For an electron, charge of an electron is 1.6 into 10 to the power of minus 19. And what about E? Electric field is given 2 into 10 to the power of 4 plus 4. Now what else is left? Only thing that is left is you have to simplify it and calculate. Now you are not allowed to use a calculator in the KCET exam, so you have to adapt without using calculator. So if you are solving it using calculators, stop doing that. You have to stop using calculator right now, so that your calculation, your brain is basically a machine. If you are not using the machine, then you are basically it will accumulate rust. Okay, over time it will accumulate rust and it will not be able to function as it's supposed to. So that's why stop using calculators for all the purposes. When it is allowed in the board exam or in your school exams, college exams, you can use it, but till then, apart from that exam, do not use calculators. Okay, so now 2 cancels. Now approximation. It is very, very important to learn about approximation. So 1.6 and 1.5, because they are so close, we will say 1.5 and 1.6 almost cancel. Almost cancel. Now what is left? Because on our left hand side we have a t square, so we have to find a square root. We have to assume that 9.11 is very close to 9. 9.11 is very close to 9. Okay, because that is a whole number. You can easily take the square root of this number. That's why it is 9. Now let's simplify this. 10 to the power value simplification is important. So 10 to the power of minus 31, 10 to the power of minus 2. Okay, in the division we have 10 to the power of minus 19. So in division means when it goes up, it becomes plus 19. And we also have a plus 4 in the division, so when it goes up it becomes minus 4. Now basically you have to simplify the 10 to the power value only. If you simplify 10 to the power of value, you will basically able to answer this question. So 37 minus 37 plus 19, which will be 18, minus 18. So it will be 10 to the power minus 18. So this is the value of t square. So t square is equals to 9 into 10 to the power of minus 18. So t must be equals to square root of this value, 9 into 10 to the power of minus 18. So that will become 3 into 10 to the power of minus 9. So obviously, because you have approximated, your answer will not match exactly, but you will get a very, very good, very close answer based on your solution, right? So yes, Shiv Charan is correct. Answer A is correct answer for this question. Now let's move on to the next question. What will be the total electric flux through the faces of the cube as given in the figure with side of length A if a charge Q is placed at B? So a charge Q is placed at B. Okay. Midpoint of the edge of the cube. Okay, now what will be the electric flux through this cube? Now it would be easier if the charge was situated inside. Anywhere inside, the problem would have been very, very simple, Q by epsilon naught, right? But because the charge is on the edge, the charge is not completely inside. It is not completely outside as well. It is not completely inside. It is not completely outside as well. So it can be tricky if you don't know how to solve this kind of question. So the very easy way to solve such question, there is one more variety where charge is located at the corner, which is slightly trickier and trickier. This one is slightly easier. Okay, so here basically you have a cube. Let me use the draw tool. So basically you have a cube. Okay. The charge is located at the edge. The charge is located at the edge. Now, how many cubes you have to construct so that this charge is completely inside? How many cubes you have to construct so that this charge is completely inside? You have to construct a cube over here. Okay. You have to construct a cube over here. You have to construct one cube over here and one cube over here. So total, how many cubes are there? 1, 2, 3, 4. So 4 cubes you have to draw to keep this charge completely inside the boundary. So that means if this is the configuration, then total flux would have been Q by epsilon naught, right? This would be the total flux through this entire system. Now here these 3 cubes are missing, only 1 cube is there. So the total flux will be 1/4 of the entire thing. So 4 cubes were required. Out of the 4 cubes, 3 are missing, only 1 is present. So it will be 1/4. So very interesting question. You should try the option where the question is given that charge is located at the corner. In that case, what would be the electric flux? So here it is easy. So answer is option C, right? Now let's move on with the next question. Just give me a moment. Next question. Consider 3-point charges minus Q, Q and minus Q. So minus 2Q, Q and minus Q. 3 surfaces S1, S2 and S3. So this is S1, this is S2 and this is S3. So 3 surfaces are there and 3 charges are there. Okay. Match the entries of list 1 with that of list 2. So net flux through S1, net flux through S2, net flux through S3. And after the matching is done, you have to find the correct match. I will give you few seconds to answer this question. So if you see that here in S1, net flux is basically minus 2. So if you take the S1 minus 2Q plus Q. So total charge enclosed for S1 is actually equals to minus 2Q plus Q, which is equals to minus Q. So the flux through S1 will be minus Q by epsilon naught. Very simple. What about S2? So S2 has plus Q minus Q. So total charge for S2 will be plus Q minus Q. That is 0. So flux through S2 will be also 0. What about surface S3? So total charge S3. So S3 is the superset. It contains everything. All the charges is included inside this charge. It resembles the Venn diagram that you have studied in your lower classes, right? Now for S3 entire, all the charges are included. So minus 2Q plus 0. So the charge enclosed here is minus 2Q. You don't need to add these two because this is already 0. You have already calculated that for S1, S2. So total charge is only minus 2Q. So the flux through S3 is minus 2q by epsilon naught. So the matching is done. So flux through S1 is minus q by epsilon naught. Okay, flux through S2 is 0 and flux through S3 is minus 2q by epsilon naught. So A is 2, B is 3, A is 2, B is 3, C is 1. So correct match is option D. Okay, match the followings. In many cases, if you do one or two proper matches, the other options automatically follows. So because there are three options, if you can match two of them, the third one will automatically follow. Right, now let's move on. Now questions from 2025. A metallic sphere of radius r carrying, hi Shamid, try to answer the following question. A metallic sphere of radius r carrying a charge q is kept at a certain distance from another metallic sphere of radius r by 4. So here are two spheres. One is radius r, another one is radius r by 4. Okay, carrying a charge q. Okay, so this one has small q charge, this one has capital Q charge. What is the electric flux at any point inside the electric flux at any point inside the metallic sphere of radius capital R due to the sphere of small r by 4. So what is the flux inside? Okay, inside this sphere due to this smaller sphere. Easy question, very easy question. So because we know that this is a conducting sphere, electric field inside a conductor is always 0 no matter what is the case. So as you can see, this surface is located outside this sphere, so that means electric flux inside will be 0. Electric flux inside will be 0. No need to think too much. Easy question you should answer. No, Chetan, it is wrong, not option 3. Option 3 is incorrect because this charge, this sphere is located outside. This sphere first of all located outside. So outside means we do not need to consider. Gauss's law says that whatever charge is inside, that should be the flux. Okay, so even if there is a flux, if some flux lines are passing through this, whatever flux is entering, same flux has to exit as well. So that means net flux is 0. And that is also valid from Gauss's law as well. Gauss law says that charge has to be inside. If charge is outside, the flux is 0. So either you apply the flux, incoming flux equals to outgoing flux, or you apply Gauss's law. Both cases you will get the same answer, that is 0. Next, this is another tricky question. You are given a dipole of charge plus q and minus q separated by a distance 2r. A sphere A of radius r, passes through the passes through the center of the dipole. So this is the center. This point is the center of the dipole. Okay, as shown below, and another sphere B of radius 2r passes through the charge plus q. So this one passes through the center, this one passes through the plus q charge. Okay, then the electric flux through sphere A. So basically they are trying to give you a complicated system, but the question, if you read, it's easy. Okay, they are only asking you what is the flux through this sphere. So as I mentioned, Gauss's law says that electric flux depends only on the charge inside. Anything outside does not matter. So only charge inside. What is the charge inside this sphere? Charge inside this sphere is minus q. So electric flux will be minus q by epsilon naught, not 0 here. So this case the answer will be 3. This case answer will be C, 3. So when will the chemistry and math class? So Nashi, I can't. I think Nashin, if you have joined us at the beginning, we have introduced the chemistry teacher, Swati ma'am. She will start taking class as early as from tomorrow. Okay, from tomorrow onwards your chemistry classes will start. By next week your maths classes will also start. So don't worry, Okay, Nasheen, chemistry class will start from tomorrow, maths classes will start from next week, right? Now next, charges are uniformly spread on the surface of a conducting sphere. The electric field from the center of sphere to a point outside the sphere varies with distance from the center S. Now this question, first of all, is an easy question. Second of all, there is a pattern I will going to discuss in KCET exam, which is very common. Okay, so charges are uniformly spread on the surface of a conducting sphere. So if you are considering a conducting sphere, I already discussed in my last lecture that if you give some charges to a conducting sphere, charges will always stay on the surface of the conducting sphere. Okay, hollow spherical shell or conducting sphere, they act same, they act exactly same, so there is no other cases. If you give some charge will always stay on the surface. Okay, so electric field inside the conducting sphere or a spherical shell always 0. So electric field inside a conducting shell or conducting sphere is always 0. Okay, and if you have followed my last lecture, you will realize that this is the correct pattern for electric field. So it is 0 inside and it decreases like this. Now one important point to remember, that this pattern, this particular pattern, not only for this case, this is one of the most common pattern in KCET. You will see that in many chapters, many cases, this is the one of the most common pattern that if you know this pattern, you will be able to answer questions. Okay, even if you are guessing, this is the one that you have to guess. Now this is not correct, this is not correct, this is also not correct, this one is the correct answer for this question. Yes, Aisha is correct. Aisha is saying study well. I studied PCB instead of PCM. My biggest regret in 2026. Yes, Aisha, you have to study PCM and biology as well. Biology you cannot ignore. If you are unless you are core into engineering, you can study PCM. If you want to have some option open that I want to move into say some medical field, then biology is also required. Which of the following is a correct statement? Okay, Gauss's law is not applicable when so you have to find a correct statement. That means 3 statements are wrong, 1 is correct. That is easier. In some cases they will ask you find the incorrect statement. That those kind of question, or which of them is false, those kind of questions can be tricky. Okay, Gauss's law is not applicable when charges are not symmetrically distributed over a closed surface. This is wrong. Okay, charges, as long as charges are distributed symmetrically, asymmetrically, does not matter. Gauss's law is always applicable. So this statement is incorrect statement. Gauss's law does not hold good for a charge situated outside the Gaussian surface. So Gauss's law says that any charge situated outside, it will not have any influence. So this is also incorrect. Gauss's law is true for any closed surface. Gauss's law is true for any closed surface. This is the correct statement. This is the correct statement. Okay, we will check the other option as well. Gauss's law is true for any open surface. Gauss's law is not true for open surface. And remember, Gauss's law is true for any closed surface. As long as the surface is closed, does not matter its shape or size, Gauss's law is always true. Okay, so the surface can be a sphere, surface can be a cylinder, surface can be an odd shape like this. Gauss's law is always valid. Okay, it is not only valid for sphere or cylinder, it is valid for some odd shaped as well, as long as the surface is closed. Okay, now let's move on. The total electric flux through a closed spherical surface of radius small r. Yes, correct. Now let's see this question. So Gauss's law, as you can see from the PYQ discussion, Gauss's law is one of the most important topic from this chapter, right? the total electric flux through a closed spherical surface of radius small r enclosing an electric dipole of dipole moment 2aq is given epsilon naught is the permittivity of free space. Easy question. They have not given the diagram, so you have to draw the diagram to understand it. So what will be the flux? Easy question. So you have a closed spherical surface, okay, radius is given r, small r. You have a dipole inside 2aq. What is the electric flux through this surface? Yes, option A. Why option A? Because a dipole has a positive charge, a negative charge. So what is the total charge enclosed? Total charge enclosed is 0. So charge enclosed here is plus q minus q, which is 0. So if the surface enclosing the entirety of the dipole, okay, there was one question where the half of the dipole was enclosed, so we considered only the half of the charges, but here entirety of the dipole is enclosed by the surface. That means the total charge enclosed is actually 0. So if the total charge enclosed is 0 means the flux is 0, right? Now next question, little longer question. Under the electrostatic condition of a charged conductor, which among the following statement is true? Now this question is partially from the second chapter, that is electrostatic potential and capacitance, and partially from this chapter. So combining those two chapters, this is a question. So I will not say that this question is purely from this chapter. I should have given this question in the next chapter. Anyway, let's try. The electric field on the surface of a charged conductor is sigma by 2 epsilon naught. So you have to find the true statement, correct statement. Okay, the electric field on the surface of a charged conductor is sigma by 2 epsilon naught, where sigma is the surface charge density. The electric potential inside a charged conductor is always 0. Any excess charge resides on the surface of the conductor. Net electric field tangential to the surface of the conductor. Now let's see one by one. So you may have seen that infinitely charged sheet. For an infinitely charged sheet, the electric field is sigma by 2 epsilon naught. But here it is neither infinite, it is not a normal sheet, it's a conducting sheet. For a conducting sheet, the electric field is sigma by epsilon naught. We will learn about that in our next chapter. So this is incorrect statement. This is incorrect statement. For charged conductor, the electric field near the surface of the conductor is sigma by epsilon naught, not sigma by 2 epsilon naught. The electric potential inside a charged conductor is always 0. This is wrong. Electric potential inside a charged conductor is constant, not 0. Electric field is 0, potential is constant. Any excess charge resides on the surface of the conductor. This is the only correct statement in this all options given. Any excess charge, if you give any excess charge, the charges will always reside on the surface of the conductor. Net electric field is tangential to the surface of the conductor. Net electric field is always normal. So this is also from electric field chapter. So net electric field is always normal to the surface of the conductor, not tangential. This is also incorrect statement. So these three statements are incorrect. Only one of the statement is correct, that is option C. No, this is not correct. Option A is not correct. Option C is correct. This is true for infinitely charged sheet, non-conducting sheet. For conductors, it is sigma by epsilon naught. For a conductor near the conductor, the formula is sigma by epsilon naught, not right? Now, uniform electric field E equals to, so far most of the questions are not too hardcore mathematics, right? Most of them can be solved within few seconds. Now we are having some mathematical question as well. Uniform electric field E equals 3 into 10 to the power of 5 Newton per Coulomb is acting along the positive y-axis. The electric flux through a rectangle of area 10 centimeter into 30 centimeter whose plane is parallel to the zx plane. So electric field is acting along y-axis and zx plane means this is zx plane. Okay, so basically what you have to do, you have to so electric flux is E dot A or EA cos theta. In this case cos theta is 0. Okay, surface area is also in this direction, electric field is also in this direction, so the cos theta is 0, that is 1. Cos theta is 0, so cos 0 is 1. So only thing you have to calculate is EA, as simple as that. Electric field is given 3 into 10 to the power of 5. Okay, area, while calculating area, only one precaution that you have to take, because the distances are given in centimeters, you have to convert them into meters. That's it. So 10 centimeters will give you 10 into 10 to the power of minus 2. 30 centimeter will give you 30 into 10 to the power of minus 2. So that is only one thing that you have to do by yourself. Everything else is given inside the question only. Okay, so just multiply. 30 into 3 is 90. 90 into 10 is 900. 10 to the power of 1. 10 to the power of minus 2, minus 2, 10 to the power of minus 4. 10 to the power of minus 4, 10 to the power of plus 5, that is 10 to the power of 1. So you can say that this is 9 into 10 to the power of 3. So the answer is 9 into 10 to the power of 3. Okay, if you have even calculated the basic values, the answer will be actually multiplier of 9, you should easily find the answer, right? Now let's move on to the next question. I hope this is easy question. Sir, when KCET results will come? Siddhant Naik, as I already explained in one of my videos, that there was some problem happened in the agricultural practical exam, so that's why they have reconducted the practical exam, I think 1st of June. So only 3 days have passed. By the end of this week or the beginning of the next week, we can expect the KCET results. Okay, and don't worry, KCET counseling will be slightly delayed as per my understanding from 2024 experience. 2024 there was multiple issues there, but because the NEET exam got delayed, okay, generally what happens, some students who either opt for engineering or medical, they apply for both of them. Now if they get a seat on engineering, later on they want to opt for medical, sometimes it creates problems. So that's why they try to do engineering counseling and medical counseling parallelly as much as possible. So that's why I feel that the counseling process will be delayed. Even though the results will be announced, the counseling process will be slightly delayed. It will come out either end of this week or maybe beginning of the next week. Okay, so that is the expected turnover time. A body has a charge of minus 3.2 Coulomb. The number of excess electron it has. So very easy question. Q equals to N into E. Now for this question, because 3.2 is a multiplier of 1.6, we will use the basic formula, that is Q is equal to Ne, or number of electron is actually Q upon E. So what is Q? Q is 3. We will not consider the sign. Sign means either excess electron or lack of electron. That's it. Sign is not important. Okay. So Q is 3.2 into 10 to the power of minus 6 micro. So consider that as well. And charge of an electron is 1.6 into 10 to the power of minus 19. Okay, this is all known. So now simplify. So you will get 2 here. 2 into 10 to the power of 13. So the correct answer is 2 into 10 to the power of 13. Very easy question. Even if you without solving also, you know it will be multiplier of 2. Only one case there is a 2, so that will be the answer. Right? Easy. Sir, taking draw for KCET is it bad? Aisha, so it depends on mainly 2 things. Okay. First of all, how good was your PUC results? If you have a very good PUC result, say for example you have 270 plus marks in PUC, okay, and you are focused, because what happens, you know, I am telling you a true story. One of my friend, they took a drop after failed into the JEE exam. Okay, that JEE means that time there is only one JEE, IIT JEE. Okay, and when I was a student, only IIT JEE was there, and there was one exam that is for separately for other government colleges. Okay, there was no I forgot the name. I think AIEEE or something like that was there. Okay, AIEEE, yes. So AIEEE was there, and JEE advanced or IIT JEE was there. Okay, so he was so much hardworking and he did not get a good rank in IIT JEE. He wanted to study from IITs, and that point of time there are not too many IITs also. I think 4 IITs were there at that point of time. He wanted to study from one of those IITs. He did not get the seat, so he was very disheartened. He took a drop. Okay, and what happens in between, he lost his complete hope. Okay, he lost his hope, he got frustrated. Later on he took a admission in a college for general course, and then he succeeded in life. That is separate. But if you are someone who will not lose your hope, and for KCET, particularly for KCET exam where board marks are also important, if your board marks are high enough, and if you are dedicated, if you think that I can sustain, because right now you just came out of the process, right? So your mind is still energetic, but what happens after 6 months, you start losing your energy, because you see your friends are starting there, they are saying, "Arey, I go to the college, you know the college, what happens is there," etc., etc. So you will start hearing from them and you feel, oh, I am missing that life. So that is one thing happens to you. But if you can stay out of the noise, if you stay focused, then that is definitely you can take a drop. So 2 conditions. First condition is your PUC marks should be high enough. Okay, because only having a good rank, good marks in KCET is not super important. It is only 50% good enough. So if you are thinking that I have say 250 or 240 marks in my KCET, should I take a drop? I think it will not change by a much. Okay, so in whatever colleges you are getting right now, you should take an admission and prepare your 4 years, die hard. You will do very, very good. But if you are interested, no, I want a top college only, and I want better ranks this time, so you can take a drop, but you have to have patience, and you have to have a focus. So if you think that I can stay focused, I will not lose my focus because whatever else others are saying, my goal is to get into this college, my goal is to get a good college, my goal is to get a good rank, then definitely you can take a drop. So taking drop requires a little bit of courage, encouragement from family as well. If your family is supporting you, then there is no problem from your family. Okay, because I have seen families also discourage, what I will do, you will waste 1 year. But if you are investing on that 1 year, you should invest it properly, not half-heartedly. That is one thing. And some students, what they do, I have seen some of them when I was the teacher, they join all the coaching classes. They join all the coaching classes, whatever they are doing, and they are also lose focus in between. So if you are someone who stick to 1 or 2 classes, okay, you can watch, obviously YouTube is free, you can watch whoever you want. But if you are focused that, okay, I will not get distracted in my mind, I will study properly, I will invest the time management properly, then you can definitely take a drop, right? Aisha, that is my suggestion to you. And your results are not yet out, so wait for the results. Who knows, you might get a good college, you might get a good rank, so just wait for that. Now next question, a point charge A of plus 10 microcoulomb and another point charge B of plus 20 microcoulomb are kept 1 meter apart in free space. Electrostatic force on A due to B is F1 and electrostatic force on B due to A is F2. Then what is the relation? Easy question. 2 charges are kept, okay, Q1, Q2. This one is applying a force on, both of them are positive. So this one is applying a force, say F1 on that. This one is applying a force F2 on that. Again, our great grandfather Newton told us F1 should be equals to minus F2. This is Newton's third law of motion. Every action has equal and opposite reaction. So if you consider this as action, this will be equal and opposite reaction. So opposite means there is a negative sign when you are writing in terms of vector form. So F1 equals to minus F2. Easy question, right? Now let's move on with the next question. Electric field at a distance small r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius small r, the electric field at the center E2 then. So this is a complicated, tricky problem if you try to solve it, but the thing is, if you take a curved wire of the same charge density and if you bend it into a wire, okay, then basically it gives you the same electric field. So E1 is actually equals to E2. So if you do the mathematics, you will see that the electric field is same, that is electric field due to a straight wire is given by 1 by 4 pi epsilon naught 2 lambda upon r. Same formula you will get for a charged circular ring as well. Okay, so from this we can say the electric field will be same. It will not be different, it will be same. Okay, obviously we are not doing the derivation over here. Now next, a cubical Gaussian surface has side of length A equals to 10 centimeter. Electric field lines, this question we have solved during our class as well. We are going to solve it once more in this lecture, those who have missed it. So parallel to x-axis as shown, the magnitudes of electric field through surfaces ABCD, so this is the surface ABCD, okay, is and EFGH, this is EFGH, okay, so this is EFGH, this is ABCD. So two surfaces are there. Through ABCD it is 6 kilonewton per coulomb, through EFGH it is 9 kilonewton per coulomb respectively. Then the total charge enclosed by the cube is, so very interesting question. So first of all we have to find the electric fluxes. Electric field is given, you have to convert it into electric fluxes and then find the net flux. If the net outgoing flux is positive, I discussed in my lecture also, if the net outgoing flux is positive, there must be a positive charge inside. If the net outgoing flux is negative, then there has to be a negative charge inside. So first we will calculate the fluxes. So what is the incoming flux? Incoming flux is electric field into the area. Okay, so whatever is the incoming electric field into the area of this ABCD is the net incoming flux. Okay, so area, how to calculate area? This is a cube, that means the area is a square. So 10 centimeter is given as the side. So that means incoming flux is 6 kilonewton. Kilo means 10 to the power of 3. Okay, area is 10 centimeter into 10 centimeter. You have to convert centimeter into meters as always. Remember, this trick is very, very helpful if you are converting units. So conversion of unit is very important if you are converting from 10 to the power values. Okay, now let's move on. So we get 6 into 1, 2, 5 minus 4, 10 to the power of plus 1. So you will get 10 to the power, so 6 into 10, that is 60. Okay, 60 SI unit is the incoming flux. So if you solve the same way, outgoing flux will be, so when the electric field was 6 kilonewton, you are getting flux is 60. So when the electric field is 9 kilonewton, how much you are supposed to get? Easy, you are going to get 90 10 times, because this factor remains same. This factor remains same, that means 6 kilonewton gives you 60, 9 kilonewton should give you 90. So what is the net flux? Net flux, net outgoing flux is phi out minus phi in. So 90 minus 60, is it positive? Yes, it is positive. So if the net flux is positive, then definitely the charge inside is positive. It cannot be negative. So you can ignore these two values. It will not be negative, it will be only be positive. Now what will be the value? Obviously from Gauss's law we know that total flux or net flux is basically charge enclosed by epsilon naught. So charge enclosed will be epsilon naught into the net flux. So what is the epsilon naught value? Epsilon naught value is given 9 into 10 to the power of minus 12. So you will take that, and we have calculated the net flux to be 30. So it will be 30. So you get this as 27 into 10 to the power of minus 11 or 0.27 into 10 to the power of minus 9 or 0.27 nanocoulomb. So charge enclosed is 0.27 nanocoulomb. So correct answer is option C. Okay, now let's move on. A positively charged glass rod. If you have any doubt in any one of the questions, please do feel free to ask in the chat. Positively charged glass rod is brought near uncharged metal sphere, which is mounted on an insulated stand. If the glass rod is removed, the net charge on the metal sphere is easy question. So we have a metal sphere, we have an insulated rod through which it is mounted. We have a charged glass rod, okay, positively charged, okay, positively charged glass rod. This is glass rod, this is metal, okay. It is brought near, it is not touched, it was never touched, it is brought near. So when it is brought near, what will happen? By induction, some negative charges will be induced here, some positive charges will be induced here, okay, but these charges will stay inside the metal sphere, it will not go anywhere. Now if you remove this glass sphere, what will happen? This positive negative will again balance each other, so that means the net charge on the sphere will be 0. So the net charge on the sphere will be 0. So because it is not being charged, it is an isolated system, even though you have separated the charges, but as soon as you remove the glass rod, those charges will combine and give you 0 net charge. So net charge on the sphere is 0, right? Let's move on with the next question. Now this question is slightly tricky and very hard, but we will try to solve it. I will give you the idea how to solve it. A tiny spherical oil drop carrying a net charge Q is balanced. Do not try this at home. This is like a fair warning. This question is tricky and difficult, so do not try to solve this kind of question. This is like, if you are trying to solve this kind of question, this is also you need to know the difficult question. This is the most difficult question. There was one more question from another chapter. So in the history of KCET, this is the most difficult question. There is one more which is almost equal to this, but not as difficult as this one. This is the most difficult question in the history of KCET. If you try to solve this kind of question in the KCET exam, you will waste your time, you will waste your energy. So better to skip such questions, okay. We will solve it, no, there is no doubt about it. This is JEE advanced level question. This is not even KCET level question, this is JEE advanced level question. A tiny spherical oil drop carrying a net charge Q is balanced in still air with a vertical uniform electric field of strength 81/7 pi into 10 to the power of 5 volt per meter. When the field is switched off, the drop is observed to fall with the terminal velocity of 2 into 10 to the power of minus 3 meter per second. Here G value is 9.8, viscosity is 1.8 into 10 to the power of minus 5, and the density of the oil is 900 kilograms per meter cube. The magnitude of Q is, so if you see that this is long question, okay, electric field is given, charge is not given, okay. When the field is switched off, basically it is falling with the terminal velocity. So terminal velocity, whenever you are solving a problem based on terminal velocity, you have to use the viscosity as well. So terminal velocity is given, G is given, and viscosity is given. Now to solve this question, you have to start with the very basic fact is that when the charge is moving in the electric field, okay, when the so it will basically gain a velocity, and that velocity is given here. Now we know that so the force that is acting on a charged particle, the force acting on a charged particle is given by Q into E. Okay, so here gravity is also present. Gravity is also present. Generally, when we solve problem based on electric field, we ignore the gravity because gravity is either not present or not strong enough. But in this particular case, gravity is present. So that means when the particle is falling, when the particle is trying to fall, there are two forces that is acting on it. One is mg, which is acting downward. There is electric force which was acting upward. So electric force and gravity, they are actually balancing each other so that the particle attains a constant velocity. So the particle is attaining a constant velocity means the electric field and the weight, they are basically same. Now when you switch the electric field off, this force is gone. The electric force is gone. Okay, so initially QE equals to mg. Then only it will gain a terminal velocity. Now when this force is gone, then what force is taking its place? The viscous force. The viscous force is taking its place. So what is that viscous force? The viscous force is 6 pi eta rg. This comes from the terminal velocity equation. Okay, Stokes law. Stokes law says that the in terms of terminal velocity, you can write 6 pi eta r v. Sorry, 6 pi eta r v. Okay, so v is the terminal velocity. So you are given the r, v's, q, e, everything is given, but only one problem, the mass is not given. So that makes this problem a little bit difficult and long process to solve. That r also is not given. Okay. So the r of the density is given. Okay, net charge, yes. So density of the material is given, but r is not given, m is not given. So if those two values are given, this could have been an easy problem. So how can you calculate r and m? So m is actually equals to volume into rho, volume into density. Volume is, what is the volume of a spherical charge? Say the radius of the charge is r. So the volume is 4/3 pi r cube. Okay, so this is how you calculate the relationship, and from there you have to simplify it. This is a very long process, and after solving a lot, I think you will get this as 0.8 into 10 to the power of minus 19. 0.8 into 10 to the power of minus 19 will be the ultimate answer. This is one of the most trickiest and longest, lengthiest problem. I am not going to waste the time over here, because if this type of question comes in the KCET exam, you should not even try to attempt it. You should just guess one of the answer and move forward. Okay. Good evening, Rajesh. Hello. So this kind of question you should not even try, because as you can see from this value you have to calculate the r cube. Okay, and from that this is actually equals to Fe. Okay, q is not given. Okay, so you have to find the r from this in terms of q. Okay, q into E divided by 6 pi eta v. Okay, r is gone. Now you have to put this back into this equation back again, and then you calculate the so there will be r cube to this, right? So mass will be 4/3. Okay, this entire thing's whole cube into pi into rho, right? Now you put that value back to this equation 1, and then you simplify. So that is a very long process. Okay, so r is calculated. Now you calculate the mass. Now put back into the same equation, that QE equals to 4/3 q into E by 6 pi eta v. Nothing will cancel, by the way. Nothing will cancel. That is one problem with this problem. Right? So this is how you should solve it. Now from here you have to calculate the cube, and after everything else you have to calculate cube root also, because there is a cube involved over here. So this is one of the most difficult problem, and this equation you have to basically solve. As you can see, this is not an easy equation to solve. Right? Let's move on to the next question. An electric dipole with the dipole moment 4 into 10 to the power of minus 9 Coulomb meter is aligned at 30 degrees with the direction of a uniform electric field of magnitude 5 into 10 to the power of 4 Newton per Coulomb. The magnitude of the torque acting on the dipole is. This is easy question. Hello Arif. Hello. Rajesh, if you don't know, my name is Soumik Sir. I am teaching in this channel for almost 2 years now. I think you are new, so if you are new, first of all, give this video a like and subscribe to our channel. Then you will know all of our names, okay? Who teaches biology, who teaches physics, who teaches chemistry, right? Hello, Arif. Sir, KCET result, I told you it will be either published end of this week or beginning of the week, okay? Because of the agricultural exam mishap happened, something happened in the agricultural practical exam, so they have to reconduct it. June 1st was the date, Monday it was conducted, so that because of that obviously it got delayed by a little. An electric dipole with a dipole moment is given. Torque you have to calculate. How to calculate torque? Torque is PE cos theta. Okay, so here the angle is 30 degrees given in the question. P is given, E is given, everything is given. Just you need to put the value and calculate. So 4 into 10 to the power of minus 9. Electric field E is 5 into 10 to the power of 4. And cos 30 is theta equals to 30 here. So cos 30 is root 3 by 2. Okay, now you have to simplify. 2 2s are 4, 2 5s are 10, 10 into 10 to the power of minus 5 into root 3, that is root 3 into 10 to the power of minus 4. So root 3 into 10 to the power of minus 4. So option D is correct answer. Okay, now let's move on. 4 charges plus Q plus 2Q plus Q and minus 2Q are placed at the corners of a square ABCD respectively. The force on the unit positive charge kept at the center O. So if you just read this question up to this point, you might start drawing and start calculating the values. But if you read the option, then you will realize they are not asking you about the values. They are asking you along the diagonal AC, 0, perpendicular to AD, along the diagonal BD. So basically you have to find the direction only. Mathematical calculation is not required. So this is very, very important. That is why always whenever you are solving a question, you always read the options as well. That will save some time for you. So basically you have to find the direction of force. Okay, so what are all the charges? One charge is kept plus Q, another one is plus 2Q, next one is plus Q, and this one is minus 2Q. Now what is the question? The force on a unit positive charge kept at the center O. So you are keeping a charge at the center O. So what is the center? Let's find that. Just a second. So this is the center O. This is the center O. You have to find the direction of force acting on a unit positive charge. Okay. So unit positive charge means this is a positive charge. So this positive, this is positive. So this will be experiencing a force in this direction. So this is away force. Okay, what about this positive? This is also positive. So this is positive, this is positive. This is also experience a force in this direction. Now both these charges are same. Both charges are same. So these two forces actually cancel each other. So these charges have no effect on this central charge. So this charge and this charge will have no effect on the central charge. Now I forgot to name it A, B, C, D. Okay, this is the name. Okay, now what about these two charges? So if you see here, so if you see here, this positive charge will apply a force in this direction. This positive charge will apply a force in this direction. And what about this negative charge? This negative charge will apply a force. It will attract. Positive, positive repels. Positive, negative, they attract. So in that case what will happen is this negative charge, just a second, this negative charge will experience a force in this direction as well, right? So because of the negative charge it is experiencing an attractive force, because of the positive charge it is experiencing a repulsive force. So both these forces are acting on the same direction, that is the net force is along the diagonal B to D. So the net force is along the diagonal BD. So net force is along the diagonal BD. So if you just draw the diagram and simply analyze the diagram, you will realize you are not supposed to calculate the force, but you just need to find the direction. And direction is easy: positive, positive repels, positive, negative attracts. So just draw the arrows and see that what is the net arrow. Net arrow is along OD, so that means the force is acting along the diagonal BD. Okay, now let's move on. A charged particle of mass small m and charge q is released from the rest in uniform electric field E. Neglecting the effect of gravity, the kinetic energy of the charged particle after t seconds is. So we have also solved this question during the lecture. Let's solve it once more. Sir, today next class timing. Today next class I don't this is the class only today. There will be one more class for NEET students, not for KCET students. Okay, if you are appearing for re-NEET, there will be one more class. You can go to our channel and you can check the schedule as well. Okay, its class should have been scheduled by now. And tomorrow there will be a chemistry class, right? Saturday, Sundays we are not taking classes as of now. Charged particle mass m and charge q is released from the rest in uniform electric field E. So if you release a charged particle from rest in electric field E, so what is the force? Force will be equals to q into E. So always remember, force acting on a charged particle is given by q into E, and from Newton's second law, father equals to ma, so force equals to ma, so A equals to QE by m. Acceleration equals to QE by m. Now when the charged particle is accelerating for t seconds, when the charged particle is accelerating for t seconds, what will be the velocity of the charged particle? The velocity of the charged particle will be equals to u plus at. The velocity of the charged particle will be u plus at. Now because it is starting from rest, u must be 0. That means the velocity after t seconds will be a into t. Put the value of a, which is q e into t by m. So we have calculated velocity. Only thing that is left is calculate the kinetic energy. Kinetic energy is half m v square. The simple formula, just put the value and calculate. So it will be half m into QET by m. Whole square. Just put the values. Now simplify it. Half m into q square e square t square by m square. So now m, one of the m will cancel and you get q square e square t square by 2m. Okay, so it will be q square e square t square by 2m. So option C is correct answer. How many questions are there? Almost few more questions are there. An object of mass 2 grams located in a region of uniform electric field E equals 300 Newton per Coulomb I cap carries a charge Q. The object released from the rest at x equals to 0 has a kinetic energy of 0.12 joules at x equals to 0.05 meter. Then Q is. So this is almost same question as the previous one, only in this case time is not given. They have given the question in terms of x, and kinetic energy is given. You are asked to find the charge Q. So how to do that? We know that force acting on a charged particle is Q into E. Same style. Style is same. Okay. Only thing is the formula will be slightly different at the end. Now that is equals to ma, or A equals to Q into E by m. Okay, so acceleration is calculated. Now distance you have to calculate, and from distance you have to calculate the velocity. Okay, so v square equals to u square plus 2ax. Okay, 2a is because it is given in as a x, we are writing x. So v square is equal to u square plus 2ax. Now because it is starting from rest, u must be 0, so u square is also 0. So v square equals to 2 into q into E by m. X is 0.5. So 0.5 into 2 is 1. So that is q into E by m. So v square is equal to q into E by m. Now what is the kinetic energy? Kinetic energy is given by half mv square. We already have calculated v square as it is. So just put the value half into m into q into, sorry, I was in capital Q. So capital Q into E by m. Do not add a square on this as well, because already v square itself is calculated, so no need to add another square. So m cancels. Now you put the value. So kinetic energy is given 0.12 joules, half into charge we are trying to find, and electric field is given 300. Okay, sign we will come to it later on. Okay, so Q is basically 0.12 into 2 divided by 300. Okay, so it will be let's calculate 24 by 3 into 10 to the power of minus 4. Okay, 1 2 zeros, so 2 0 was in division, point decimal of 2 point decimals was there in the numerator, so it becomes 10 to the power of minus 4. So just be accustomed to this kind of calculation. So 0.12 can be written as 12 into 10 to the power of minus 2. 1 by 300 can be written as 1 by 3 into 10 to the power of minus 2. So basically these two becomes 10 to the power of minus 4. Okay, 3 8s are 24. So it will become 8 into 10 to the power of minus 4. Okay, or you can write this as 800 microcoulomb. Micro means 10 to the power of minus 6. So if you are writing this as 10 to the power of minus 6, you can write it 800 into 10 to the power of minus 6. So this is 800 microcoulomb. Now whether it is positive or negative, that we have to figure out, because positive and negative both values are given. So don't rush. You have solved the question 800, you got the answer. So either C or D will be the answer. So make sure you read the question once more. An object of mass located in the region uniform electric field I cap carries a charge Q. Object released from the rest x equals to 0 has a kinetic energy of 0.12 joules at x equals to 0.5 meters. So it is moving in the direction of the electric field. The charged particle is moving in the direction of electric field, because the electric field is along the positive x-axis I cap. So electric field is in the positive x-axis. So this is the direction of electric field. Particle was released at x equals to 0 and it reached x equals to 0.5. So the particle is moving in the direction of electric field. Which charge particle moves in the direction of electric field? Only positive charge moves in the direction of electric field. That means the charge is positive in nature. Okay, so charge is positive in nature, so option C is correct. In the case the electric field is given negative, or the distance was negative, then in that case you have to be careful and you have to say that the charge is negative. Here everything is positive, that means charge is also positive. Now let's move on. Electric field due to infinite straight uniformly charged wire varies. Hello Prem. Electric field due to an infinite straight uniformly charged wire varies with distance smaller as. So electric field due to a infinitely charged wire at some distance is given by 1 by 4 pi epsilon naught 2 lambda upon r. So electric field varies as 1 upon r. So easy question, easy peasy lemon squeezy. Now next question, a copper rod AB of length L is rotated about end A with a constant angular velocity omega. The electric field at a distance x from the axis of the rotation is. So here we have a copper rod. This is an interesting question. So let me use a diagram. Suppose this is the copper rod, okay, and it is being rotated around some axis. Okay, now we are trying to find electric field at a distance x from the axis of rotation. Okay, so we are trying to find electric field at a distance x from the rotation. Now nothing else is given. So how to find the electric field? So when an electron, suppose we have an electron over here at this position, we have an electron which at a distance x, we have an electron that is also rotating along with the rod. It's a conducting rod, so it will have some electron inside it as well. So the electron is also rotating along with the rod. So what will happen to this electron, that you have to be careful about. So when something is rotating, the force that is necessary for rotation is called centripetal force. The force which is necessary for rotation is called centripetal force. So this electron will experience a force which is centripetal force along the center towards the center. Okay, what is the formula for centripetal force? If you remember, it is mv square upon r. Okay, the centripetal force is mv square upon r. But if it is, you are writing in terms of angular velocity, the formula becomes m omega square r. So in terms of angular velocity, the formula becomes m omega square r. So this is the centripetal force. Now centripetal force is something which has to be provided by someone else. Okay, it is not a natural force. For example, gravity is a natural force. So some satellite orbiting in the around Earth, okay, so that satellite requires centripetal force to maintain its motion, maintain its circular motion. Now who provides the required centripetal force? Gravity provides the required centripetal force. Some natural force has to provide the required centripetal force. So because we are considering an electron, and suppose the electric field here is E, so in that case this must be equals to Q into E. Q into E is natural electrostatic force. Q into E is natural electrostatic force. So some natural force has to provide the required centripetal force. So here electrostatic force is a natural force, so that has to provide the required centripetal force. Now instead of R, we will be using X because the distance is given here as X. So distance given here as X. So from here we can basically calculate the electric field. Electric field is very simply m omega square x by E. So charge of the electron is E, so it will be m omega square x by E. Interesting question. Nothing is given, but you can still figure it out if you just go through little basics. It is a little deeper question, but easy question. When a soap bubble is charged, you have a soap bubble. You charge it. What will happen to the soap bubble? Right? The soap bubble, if you apply some charges on the soap bubble, what happens is that, okay, the charges will start repelling each other. The charges will start repelling each other, okay, because it wants to stay as far as possible. So the radius of the soap bubble will increase. Okay, so because it's a soap bubble, it can change its shape and size. So the radius of the soap bubble will increase. Okay. So radius increases, its radius increases. Next question. This is the last question of the day. The electric field lines on the left have twice the separation on those on the right as shown in the figure. If the magnitude of the field at A is 40 volt per meter, what is the force on a 20 microcoulomb charge kept at B? So first of all, if you see that here the distances are close, here the distances are bigger. Okay, and electric field is proportional to the distance between the field of lines of forces. Okay, so electric field lines, closer the field lines, stronger is the electric field, and it is also proportional. So if the electric field here is given as 40, if the electric field here is 40, the electric field here must be 20, because the distance increases. Farther they are apart, weaker the electric field, closer they are, stronger the electric field, and it is proportional to the distance between the field as well. So here the electric field is 40, so here the electric field must be 20, not 80. Remember that. Okay, distance increases, electric field decreases. Okay, so electric field here is 20. Now the charge given here is 20 microcoulomb. So the force acting on the charge is given by Q into E. Okay, so force acting on the charge is given by Q into E, 20 microcoulomb. Micro means 10 to the power of minus 6, and electric field is 20. So you get 400 into 10 to the power of minus 6, that is 4 into 10 to the power of minus 4. Easy question. 4 into 10 to the power of minus 4 Newton. Now this is the end of today's lecture, and if you have any questions, any suggestions, please do tell me in the comment section below. Right, if you have any doubts also, please mention in the comment below, and also like this session. If you are new to the channel, don't forget to subscribe and share our videos with your friends, so that they also learn along with you, and we get motivation to make more videos. Right, that is one thing that we are lacking. We need the motivation to make more videos, more live sessions, right? And we like to being it interactive. So if you have any questions, any doubts, do ask me in the live chat as well, right? I will see you with a new lecture very soon. Till then, bye.